Hey, welcome to NGSS Physics. We are going to be going over energy. This is lesson 4.1. And if you are following along in the NGSS Physics book, this is section 6.5 and 6.6. Okay, let's start off by reviewing the two major forms of energy. One of those major forms is called kinetic energy. And kinetic energy is the energy of motion. So if anything is moving, it's got kinetic energy. And that motion really involves two main factors. One, the velocity, and the other, the mass. And so both the mass and the velocity is directly related to the amount of kinetic energy a substance has. An increase in mass means an increase in its kinetic energy, just like an increase in velocity means an increase in its kinetic energy. They are all directly related. The other type of energy is called potential energy. And this energy is not the energy of motion. This is actually stored energy or energy that's waiting to be used. Usually we use potential energy to do something called work. Well, you could do work on an object to put potential energy right back into it, just like you can use potential energy to get work. Take a look at this rubber band. As you pull it, you are actually putting some work into the rubber band, and that rubber band is then building up potential energy in which it could be used when it springs back. Or, you could get gravitational potential energy by changing an object's position according to how high it is off the ground. Based on its position or how high it is, you can have more potential energy or less. Of course, work is involved in doing this. For instance, if you pick up a book and put it on a desk, you would be doing some work to get it from the floor to the desk. Take a look at these pictures. What type of energy do you think you're looking at? Well, if there's motion, then it's kinetic. If it looks like you put some work into it, you've got potential energy that's being stored as it waits to snap back, just like the bow and arrow. It's about to do work on that arrow. And anytime you see something moving, that's your indication that it's kinetic energy. In the momentum section, we had a law of conservation of momentum. Well, momentum is really energy. And so the law is really a law of conservation of energy, which simply means that energy, although it can be changed from one form to another, from potential to kinetic and back again, the overall energy of the system will never ever change. This is the law of conservation of energy. So anytime you have a closed system, if you calculate the potential and kinetic energy in that system, it always will remain the same number, even if there's a transfer of energy from one form to another. Take a roller coaster. Any place on this roller coaster, the sum of the kinetic energy and the potential energy will be the same number. It doesn't matter if you calculate things really high on the roller coaster, where there's lots of potential energy and probably very little kinetic energy, or really low on the roller coaster, where there's probably lots of kinetic energy and very little potential energy. The sum of the KE and PE on both of these cases will end up being the same number for the same roller coaster. Take this example, A, B, C, and D. All of these cars will have different potential energies because they're at different heights. And they likely have different kinetic energies and they're going different speeds. If you add up the kinetic energy and the potential energy of any single one of these situations, they will be the same exact number as the situation for any of the other points on the roller coaster. Here's a sample question. Let's rank order things in increasing kinetic energy. Remember, kinetic energy is the energy of motion. And you'll probably say that up here at the top, it's not moving at all, and it probably isn't. So that would be the least kinetic energy. And then over here with Y, I would say that is probably the second least kinetic energy because it slowed down after it went up. And then Z would probably be the third, and X, way down here at the bottom, is probably going the fastest. So Number 1, I would rank it order at W, Y, Z, and X. Number 2, rank order in increasing potential energy. Well, remember what we said in the last slide, okay? If we add them together, they should be equal all across the roller coaster. So I would say that these letters are going to be going in the opposite direction. Remember, potential energy is stored energy, and X has the least amount of stored energy because it's at the lowest point. As we get higher to Z, it has a little bit more potential energy, and then Y, and then W. So for number 2, I would rank order it X, Z, Y, and W. Let's take a look at some energy diagrams at the top. Energy diagram A is showing an energy diagram where all of the energy is potential. So you can see the total energy equals just the potential energy. Where would I find that on my roller coaster? I'm going to say probably up here. This is where it has only potential energy. Energy diagram B has exactly half and half potential and kinetic. So the energy is split between those two. Where would the car be half kinetic and half potential? I'm going to say over here at Y when it's about halfway up. Now assume that there's some friction. I want to remind you of what friction is. Friction is a force that resists the motion. And when we talked about forces, we said that there were many different types of friction. There's the frictional forces of air. There is the frictional forces of water. There is just frictional forces of walking on, or in this case, the roller coaster sliding on the rails. And a lot of times, the frictional forces that resist motion will result in something called thermal energy. A little bit of heat will be given off. So some of the energy, that potential energy as it's being used in kinetic energy, will be lost in the form of heat. That's what happens in the real world. So let's take a look at this. The energy diagram in C is showing us an equal amount of potential energy and kinetic energy, and a little bit of friction has probably been given off. I'm going to call that probably Y. And in energy diagram D, we have a lot more kinetic energy, and we have very little potential energy, okay? And a little bit of thermal energy. I'm going to call that Z because of that little bit of potential energy. It's a little bit higher off the ground than X. X looks like it's right on the ground. All right, so of those two main types of energy, potential and kinetic, what are some of those common places that we can find these energies? What are we really talking about? Let's take a look at some of the sources. What are some types of kinetic energy? Remember, energy of motion is called kinetic energy. So think about things that are moving. The main type is called mechanical energy, and that's when we're talking about just somebody walking or machines moving, the wind flowing. Another type of kinetic energy or motion is sound. Sound is actually vibrations that transfer through a subject. So we have molecules moving to create sound. This is why in the vacuum of space, there is no sound because there are no molecules to move. Other sources of kinetic energy are thermal energy, or heat energy. Once again, the molecules are moving, okay, to create that thermal energy. And you can make fire by moving something really fast, creating friction. Okay, there are many, many types of energy turned into thermal energy to do work. Radiant energy, energy on the electromagnetic spectrum, like light, are also considered kinetic energy. Electrical energy itself, the movement of charged particles down a wire, are actually electrons going from one spot to another. So it is the energy of motion, kinetic energy. All of these are types of kinetic energy. How about potential energy? Remember, potential energy is stored energy. Chemical energy, okay, this is energy stored in the bonds between atoms. And when those bonds are broken, that energy can be released. Coal has lots of energy stored in the bonds. Gasoline all those carbon hydrogen bonds and the OO bonds when we do a chemical reaction, all of that energy is released and used to do work. Batteries has lots of stored energy. Gravitation, believe it or not, the distance between objects, okay, or the height, and that would be your distance between you and the earth, gives you stored gravitational energy. Other types of potential energy, the nuclear energy that's stored in the nucleus of an atom can be harnessed. Okay, and when it is harnessed, we can convert it into kinetic energy to do some form of thermal work. Spring or elastic energy can also be stored. In summary, okay, we've got two main types of energy: kinetic energy, the energy of motion, and potential energy, energy that is stored. When energy changes from one form to another, potential to kinetic or back again, or just from one type of potential energy to another type, the total energy remains constant. Thanks for listening. I'll see you back in the regular classroom.